Commutative property with respect to addition. We are checking in the set of whole numbers. Whole numbers are having these kinds of numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8. It's going to infinity. So what is the commutative property with respect to addition? A plus B is equal to B plus A. If the left-hand side and the right-hand sides are equal, then it means that commutative property with respect to addition is satisfied. So you can choose A and B, any two numbers from the given set of whole numbers. So let's select 2 and 3. 2 plus 3 is equal to 3 plus 2. This is called commutative property. Both sides are equal. 5 is equal to 5. Both sides are equal. So this property is satisfied. Now let's take A and B, some other numbers. So I'm taking 100 and 200. Let's take 100 and 200. A is equal to 100 and B is equal to 200. We are checking the commutative property. A plus B is equal to B plus A. Is equal to 200 plus 100. Again, both the sides are equal. 300 and 300. So this property is satisfied by checking these two examples. And you can check other examples also. This property will be satisfied whatever number you take, A and B, from whole numbers, from this given set of whole numbers. Now, let's see another question. Commutative property with respect to multiplication. We are checking in whole numbers. We already have discussed the whole numbers are 0, 1, 2, 3, 4, 5. It's going till infinity. So what is the commutative property with respect to multiplication? A multiply B is equal to B multiply A. Both the sides should be equal. So let's select some of the elements from whole numbers. So let's take 5 and 6. 5 multiplied by 6 is equal to 6 multiplied by 5. It is showing that 30 is equal to 30. 5 6 are 30 and 6 5 are 30. So this property is satisfied. Now let's take other whole numbers. 9 and 10. A is equal to 9 and B is equal to 10. Now we have to check B multiplied by A. 10 multiplied by 9. It is same. 90 is equal to 90. So this property is satisfied with respect to multiplication. So you can take any whole numbers. From the set of whole numbers, this property will always be satisfied. Now, another question is commutative property with respect to subtraction. You have to check in whole numbers. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going till infinity. These are the whole numbers starting from 0. So you have to check A minus B is equal to B minus A. This is the commutative property with respect to subtraction. So you can check A is equal to 3 and B is equal to 4. Right? So B is equal to 4 and A is equal to 3. These two sides are not equal. 3 minus 4 will give you minus 1. And 4 minus 3 will give you 1. So the left-hand side and the right-hand side are not equal to each other. So this property is not satisfied. Now you can take any other example. So 1 and 4. 1 minus 4. Now 4 minus 1. Not equal. 1 minus 4 is minus 3. And 4 minus 1 is 3. It's not satisfied. Take one more example. 3 minus 8 is equal to 8 minus 3. This is called commutative property with respect to subtraction. It is not satisfied. Both the sides are not equal. 3 minus 8 will give you minus 5. And 8 minus 3 will give you 5. It's not satisfied. You can take any other whole numbers. This property will never be satisfied with respect to subtraction. Commutative property with respect to subtraction is not satisfied in whole numbers. Now, another example, another question is with respect to divide. Commutative property with respect to division. You are checking in whole numbers. You know that whole numbers are starting from 0. 0 till infinity. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, going till infinity. What is the commutative property with respect to division? This is the property. A divided by B is equal to B divided by A. You can write like this also. A divided by B is equal to B divided by A. You can check this. Let's take 2 and 3. A is 2 and B is 3. 2 divided by 3 is equal to 3 divided by 2. We have to check both the sides are equal or not. Or you can write like this, 2 divided by 3 is equal to 3 divided by 2. This is never equal to each other. You can check 2 divided by 3 will give you 0.66. It's not equal to 3 divided by 2. 3 divided by 2 will give you 1.5. It's not equal. It's not satisfied. Let's take one more example of commutative property with respect to division. Another example, you can take 5 and 6. 5 divided by 6. Just check, is it equal to 6 divided by 5? It's not equal in any case. A and B should be different elements, right? So now we are checking 5 divided by 6 is equal to 6 divided by 5. 5 divided by 6 will give you 0.833. It's not equal to 6 divided by 5. 6 divided by 5 will give you 1.2. It's not equal. This is not satisfied. Okay, 6 divided by 5 will give you 1.2. It's not equal to 0.8333. So commutative property is false with respect to division in the set of whole numbers. Like this, you have to check all the properties, commutative property with respect to addition, multiplication, subtraction, and division.